Hi students, welcome back. Today we will study about different forms of energy. This is a continuation of the chapter Work, Energy and Power. In this video, we will see what is energy and its different forms, then what is kinetic energy and potential energy, then conversion of energy from one form to another. So let's start. The energy possessed by a body due to its state of rest or of motion is called mechanical energy. Mechanical energy is equal to potential energy and kinetic energy. What is kinetic energy? It's energy of an object due to motion. Potential energy, stored energy of an object. Let's see kinetic energy in detail. The energy possessed by a body by virtue of its state of motion is called kinetic energy. It's given by the formula half mass into velocity square. From this formula we can know that kinetic energy depends upon mass and velocity. More the mass, more is the kinetic energy. More is the speed or velocity, more is the kinetic energy. How did this formula come? Let's imagine, suppose there is a body of mass m and is moving with a velocity v. It is brought to rest by applying a constant force f. Now the final velocity here is, it's brought to rest means final velocity is 0. So I have written here initial velocity as v, then final velocity as 0 as it is brought to rest, and it's applied by applying a force. So I have written as retarding force is equal to force is mass into acceleration, but here the acceleration is in negative, so it's minus retardation. Now what we know, this is an equation of motion, states that v square is equal to u square plus 2as. So what is final velocity here? 0, brought to rest, right? Initial velocity v, 2 in place of a minus a because it's retardation into s. So from this we get s is equal to v square by 2a. We all know that retarding force is mass into acceleration. What is the kinetic energy of the body? The kinetic energy of the body is equal to the work done by the retarding force in stopping it. What is work? Work is always kinetic energy is equal to work, and work is equal to force into displacement, right? In place of force I have written mass into acceleration, and in place of s I have calculated this v square by 2a. So a cancel, so what it will be? Half mv square. From this we get the formula half mv square. So what is the relationship between kinetic energy and momentum? We all know momentum is mass into velocity. So what will be velocity here? P by m. So in place of this v we have put p by m. From this we derive that k or kinetic energy is equal to momentum square by 2m, or momentum is equal to root over 2mk. So this is a relationship between kinetic energy and momentum. You may get some problems on this relationship. Now what is work energy theorem? According to work energy theorem, the work done by a force on moving body is equal to the increase in kinetic energy. So let's see how we can prove it. Body of mass m moving with initial velocity v. When constant force f is applied on the body in the direction of force. So what will happen? In the earlier case, what happened? We had applied, a body was moving like this and we applied a force to stop it. But if the body is in this direction, moving in this direction, and apply a force in same direction, what will happen? It will increase. The speed will increase. So this work energy theorem states that if force is applied in the direction of motion of a body, it accelerates the motion and thus increases the kinetic energy of the body. The increase in kinetic energy is equal to the work done by the force on the body. So force is mass into acceleration. What is work? Work is force into displacement. So, and how can we find this displacement? From the same equation, v square minus u square is equal to 2as. From here we get s is equal to v square minus u square by 2a. So directly putting that in the work formula. In force, mass into acceleration, and in displacement we have put that s value. So it comes as half mv square minus half mu square. What is half mv square? It's kinetic energy. So kinetic energy final minus kinetic energy initial. So the change or the increase in kinetic energy is equal to the work done by the force on moving the body if it's in the same direction. So this is work energy theorem. Work is equal to the increase in kinetic energy. Now there are various forms of kinetic energy. First, translational kinetic energy. The motion of a body in a straight line is translational. And the kinetic energy of the body due to motion in straight line is called translational kinetic energy. Similarly, what is rotational kinetic energy? If a body rotates, means it's rotational motion, and the kinetic energy of the body due to its rotational motion is kinetic rotational energy. Similarly, what is vibrational kinetic energy? If the body moves to and fro about its mean position, the motion is called vibrational kinetic energy. And the kinetic energy of the body due to this motion is vibrational kinetic energy. Example can be a guitar string, right? Any string which is clamped at one end or both ends and is allowed or touched in the middle. Similarly, this pendulum, it rotates about its mean position. Then one more thing, important point here is to remember. Let's say this car is on translational kinetic energy. Why? Because it's moving straight. If I consider the wheels of the car, what I can find? The wheels rotate, right? So the wheels have rotational kinetic energy. So a body can have translational kinetic energy as well as rotational kinetic energy. So depending upon its state of motion, a moving body may possess either one or more than one form of kinetic energy simultaneously. Now, what is potential energy? The energy possessed by a body by virtue of its specific position is called potential energy. There are two types of potential energy. One is gravitational potential energy. The potential energy possessed by a body due to force of attraction of the earth is called gravitational potential energy, and it's calculated by this formula. W is equal to mgh. W is always work is equal to force into displacement. Force of gravity here is mg and height is h, so mgh. So U, its potential energy is always given by the symbol U. So U is equal to mgh. Then what is elastic potential energy? Elastic potential, whenever an external force is applied on a body, its configuration changes. As you can see in this spring, whenever force is applied, then the length changes and the width changes. So elasticity is the property by virtue of which a body regains its original configuration on removal of the external force. When I remove the weight, what happens? It regains its original position. Potential energy possessed by the body in the deformed state due to its change in configuration is elastic potential energy. Here what happens? Gravitational potential energy, at the highest point, the gravitational potential energy is the maximum, and at this point it's the minimum. There are another type of potential energy which is a chemical stored energy, as in a battery. The chemical it's like chemical energy stored, and whenever needed it can be converted. Similarly, the food we eat is a type of potential energy. The food we eat, it stays in our stomach. When we started exercising or running, then it gets converted to another form of energy. So stored energy is basically known as potential energy. The conversion of potential energy into kinetic energy. Before that, let's think of what is the difference between potential and kinetic energy. First, potential energy is the energy possessed by a body due to its position. Kinetic energy is due to its motion. Then potential energy is equal to the work done in bringing the body to its changed state. Then kinetic energy is equal to the work done in moving a body. Moving body can do before coming to rest. Potential energy, it can change only in form of kinetic energy. Whenever potential energy changes, it can only change to kinetic energy. But whenever kinetic energy can change to any other form. Let's see this example. Here a stone, first it has potential energy 100, and as it is dropped, we see that the potential energy is decreasing, and at the end what happens? Potential energy is minimum and it has all been converted to kinetic energy. Similarly, the previous example, let's see this one. Here what happens? The person has enough food in his stomach and he started running. What happens? The potential energy is getting converted to kinetic energy. Potential energy can be converted only to kinetic energy for use. Similarly, here what happens? As you can see, the cyclist has energy, and while cycling it has kinetic energy, but at the highest position it has potential energy. Again, when it is dropping down, the potential energy decreases. Similarly, here what happens? At the maximum maximum swing, it has maximum potential energy. But at the mean position, it has kinetic energy. As you can see, this graph shows at which position it has maximum potential energy and kinetic energy. Let's see this diagram. This diagram shows that the energy is 80 joules, and here potential energy is 0. What will be the kinetic energy at this place? It will be 40 joule. At here, it's 80 joule. So what are the different forms of energy? Energy first can be classified into two types. We have already studied it. One is kinetic energy, another one is potential energy. Then, as we all know that potential energy cannot be of any use, gets converted into kinetic energy so that it can be used. Then what are the different types of energy? Thermal energy means it's related to heat. Mechanical energy, objects in motion. Electrical energy due to current. Magnetic energy causes a push or attraction. Then sound energy, light energy, solar energy can be a source of light energy. Chemical energy, energy stored in food, fuel. Elastic energy, stored in objects that are stretched. Nuclear energy, stored in the center of nucleus of an atom. Gravitational energy, due to Earth's gravity. Then another energy is wind energy, possessed by fast moving air. Then hydro energy, due to fast moving water. Then another energy which is important is geothermal energy. The energy released in nuclear disintegration in the interiors of Earth gets stored deep inside the Earth and is called geothermal energy. The energy heats up the underground water to produce steam. Sometimes the natural steam may burst out from the surface of Earth as hot springs and geyser. Volcanoes are due to this geothermal energies. So let's see energy conversion form from one form to another. Here, as you can see, it shows a dam. We all know that why dam are provided in our countries at various places and rivers. Though it keeps water in control, that is the first purpose, and second purpose is the water is stored in dams so that it produces electricity. So here hydro energy is converted to electrical energy. Second, here what happens when you put this inside a wall? It makes a hole. So here electrical energy is converted to mechanical energy. Similarly, here electrical energy is converted to thermal energy on a heater or an induction top. This is thermocouple. Here what happens? Heat energy is changed to electrical energy. Here it's an amplifier. Electrical energy is changed to sound energy. Here sound energy is changed to electrical energy. Here converts electrical energy to chemical energy. Chemical energy to electrical energy, light energy or heat energy. Similarly, here what happens? Chemical energy is converted to heat and light. Here, as we can see, electrical energy is converted to light energy. Solar energy or light energy is converted to electrical energy. Nowadays, solar power bulbs are very much useful. Here, what happens? By rubbing our hand, we feel the heat. So, mechanical energy is converted to heat energy. Here, another light energy is converted to chemical energy. Burning some crisp or heat energy. Here, what? Water boils. So, what? Heat energy is getting converted. Here a burning crisp is like burning coal or any other chemical burning is producing heat. So from chemical energy to heat energy. Here what happens? Electric drive. So electrical energy is supplied and it converts to mechanical energy. Here is the process. Chemical energy first converts to electrical energy. Then electrical energy is converted to magnetic energy. This is a solenoid, right? When iron is surrounded by a wire, it behaves as a magnet. So magnetic energy. Then magnetic energy is again converted to kinetic energy. It attracts the paper clips. Here what happens? Water is falling from a great height. And since it's falling from a great height, it produces heat here. So here mechanical energy is producing heat energy. So as we can see from here, it's all are like energy changes from one form to another. The basic thing here is energy can be changed from one form to another. So point to remember, when mechanical energy changes to other forms, it's always in form of kinetic energy and not in the form of potential energy. The stored potential energy first changes to kinetic energy and then the kinetic energy changes to other form. Here automobile engine changes chemical energy to mechanical energy and heat energy. Similarly, a tree changes radiant energy to chemical energy. Hammering a nail changes mechanical energy to deformation and heat energy. Similarly, you can find every example, you can find that the energy changes from one form to another. So basically, energy can neither be created nor be destroyed. It can only be changed from one form to another. And when mechanical energy changes to other forms, it's always in form of kinetic energy. So thank you for watching this video. If you have any questions, please leave them in the comment section below. And if you like my video, please subscribe to my channel and give a thumbs up.